All right, good morning and welcome back to the latest Collision Hub webinar. We've got our friends back from Snap on today, and today we're going to be talking about advanced driver assistance systems and in particular, setting up and aiming targets. So we've got Ron back with us again, and he's going to walk us through this.
Good morning, Jason.
Without any further delay, I'm going to turn over to him. And thank you for your time again today. Appreciate it.
You're welcome, and thank you for having us. Good morning, everyone. So today we're going to do like a sequel of our last meeting where we looked at the industry, we looked at the business and what ADAS was and how it's going to impact the industry. Today we're going to do a target placement. I've got a Honda CR-V, it's a 2019, and we're going to set the target placement for the front camera that's located up here in the windshield. So before we brought the vehicle in, we actually put it on that rack. Paul, if you want to show the rack. And we did a complete alignment inspection. We checked the tire pressure, checked the tire diameters, make sure that everything was good. Oddly enough, this vehicle has 15,000 miles and all 4 tires are on the wear bars, so he needs 4 tires. But they're still within the height range for the calibration. So nothing to worry about. We're just going to put 4 tires after we're done with this. So we've got the scan tool connected. We did a pre-scan. There are no codes that can affect the calibration. And this car is clean. It's ready to go. We're going to do a target placement. The first thing we have to do with the target placement is we have to find the front center point. And this manufacturer recommends that we use a string and a plumb bob that we would hang here and let the plumb bob hit the floor, and then you put an X on the floor. And you do the same at the back. That's pretty prehistoric. We're going to do it slightly a little different. So we have a cradle right here. We're going to need a laser, and we're going to need this plate, which is the AS11. So to find the center point, it's relatively simple. We're just going to put the cradle up against the bumper, like such. Then we're going to take the laser, we're going to turn it on, and then we're going to push the button to the right to put it in self-leveling mode. And we're going to position here in the cradle in position 1. Can you come in, Paul, and show this? So we want to align the laser with the slot down here, just like that. Now we know we're positioned correctly. The next step is to align the crater so that the green line is centered on the emblem. And that the cradle is touching the bumper. Then we'll put the AS11 plate down on the ground, and it fits in there snugly. I've got my center point. I can remove the laser, turn it off, so it doesn't cut the car in two. Then we have to find the rear center point. So to do that, we're going to use this device, which has a mirror and a laser and a slot also. So we're going to the back of the vehicle. Same here, we'll turn the laser on. Then we'll put it in self-leveling mode because right now it's not in self-leveling. So you can move it, doesn't wiggle. When you put it in the self-leveling mode, you see now it kind of wiggles a little bit. So we have to center it on the emblem, and we have to line it up with the slots that are in the plate that's on the floor in the front. And we do that by looking in the mirror. Oh, we're really close. There we go. So push it a little bit. There we go. So I'm right in the middle of the emblem. If we go to the front, we're perfectly lined up the slot that's in the AS10 plate or AS11 plate. So I'm going to leave that plate there, put my finger on it, and remove the cradle. So now I've got my center line. That is the mechanical center line of the vehicle. Step 2 is to determine the distance for the positioning of that target. So the target board in this case needs to be situated 4,000 millimeters in front of the center of the front axle. So we're going to put the laser back in position 1. We're going to push the cradle up against the tire. And when you drive the vehicle in, you want to let go of the steering wheel so that the wheels steer straight ahead. And we've done that. So I'm going to turn this on, put it in self-leveling mode, align it with the slot in the bottom, and then just move it until the line is centered on the emblem there. So now I've got my center axle. So this line is centered with the center axle. I'm going to take the laser now and put it in position 2. Let me go over here, Paul. There we go. It's a lot easier this way. Now we have to line it up with a couple of slots down here. As you can see, we're going to line the laser up. Now we're perpendicular to the center of our wheel. And we're going to take a tape measure and pull that out to 4,000 millimeters. This is a snap-on calibrated tape measure. Very important. I'm going to set that in the slot right here in the middle, which represents the center of the axle. Then I'm just going to unroll the tape measure, a little over 4,000 millimeters. Again, I'm going to line it up with the laser right here. Okay, and you can see the 4,000 mark is down there. So now I'm ready to position the stand, mount the target, and finalize the calibration. So we're going to take the pin out, unlock the mast, raise it, rotate it in position, just temporarily lock it there. Now I need an additional laser. Mounts in the base right here. I have to line it up with a slot that's down there. Okay, now I'm going to move the stand until it hits that 4,000 on the tape. Can you show that down there, Paul? So I'm at 4,000. Now I need to position the stand on the center line of the vehicle. So I'm just going to slide it sideways. And when the laser hits the bottom of the slot down here and the top of the slot on the mast, I'm perfectly perpendicular to the center line of that vehicle. I'm just going to scoot it forward, back to 4,000 because it rolled a little bit. Okay, now we'll secure it in place. Move. I'll find adjustment. Next step is to level the mast or the cross beam. We're going to lower that. We can see the spirit levels. There are 2 spirit levels here for horizontal and or the side-to-side axis and front to rear. So we're going to put it up a little bit. Okay, it's level. If you want to show that, Paul. So now I'm at 4,000 millimeters. I'm centered. I just have to raise the mast or the cross beam to 1,500 millimeters. But that height is measured from the floor. So I'm going to loosen the ruler, lower it until it contacts the floor, lock it, then raise the cross beam. You can see there's a ruler graduated in millimeters. We'll go past it and right back down to it. And I'm at 1,500 millimeters. We'll lock that in position. Unlock the target holders. So this is a 2-target system. So we're going to need the Honda FC01 as indicated right down here. one of two. When you have two of them like this, the number one always goes on the driver's side. So we'll put it on the target holders. Snug up, nice and flat, no distortion, no pin cushion, no barrel. They're solid targets. Now we'll go to the back here, Paul. And we have to position the targets at 335 millimeters from the center of the post here. So I'm just going to slide and just lock it in position. Same on this side. Now, 335. So the information for the distance, the height, and the split is all included in the app. Okay, so now I'm ready to calibrate. I've got my distance, my height, I have the split. I've got the ideal lighting in here. So I've connected, I'm using a Stolus Edge. I'm gonna turn the key on to service mode. Okay, radio is off. Can you see that? Okay, we'll hit scanner. The Honda. The automatic ID, that's the best way. It found the vehicle. We'll click OK. We have done the pre-scan, so we're going to bypass that part. We're going to go to integrated driver support system. They all have different names for them. Here we have instructions. So when we calibrate this system, it will calibrate the adaptive cruise control, the collision mitigation brake system, the lane keeping assist system, the forward collision warning, and the lane departure warning. So you can't calibrate the ADAS system. You have to calibrate all the components that are part of that system, and this is what this does. So I'm going to click on continue. It says applied systems are different by country, by car model. And I've noticed that as if you go into the colder climates, they may not have all the systems integrated. All right, now we're going to go to adjustment. There's functional tests and adjustment. Normally that's where you will find the function to do the calibration. So we'll click on adjustment. We're going to do a static camera. So we can do a radar aiming, static camera. So we're going to do static on this. It says the function is to do camera static aiming with a target board, which we have positioned. We'll click on continue. You have some setup information here. Stop the vehicle, shift to neutral. When you're ready to do your calibration, make sure you put the vehicle in park because you don't want the vehicle to roll as it's trying to calibrate. And then we'll hit continue. I can see the lights flashing in the dash. It says please wait. Static camera is completed. Be sure to test drive vehicle to verify a proper operation of the system. And when we click on continue, we actually dump this information onto our Altus drive, which is a cloud drive. And that documentation is now a permanent record of this event when we calibrated this vehicle. So that's a static camera calibration on a Honda CR-V. Not very complicated. It took us, what, 15, 20 minutes maybe at the most. When you get really good at it, 10 minutes, you're done. In some cases, you may have a scan tool that does not have this model year coverage. Not a problem. Just get a J2534 tool and you can connect to the vehicle, then you'll have 100% coverage with the manufacturer. You just pay as you go. For example, this Honda, if I were to connect a JA box, I would have to go to Honda, pay a $30 subscription fee, and that's for 24 hours, and I could do this calibration. So if it was a 2020 or a 2021, for example, they have the info, they are updated. The scan tools, the aftermarket, it takes a little longer to get the information in, but with the 2534 box, you'd be up. So with a 2534 box and a scan tool, you'd have all the coverage required for all the systems. I'm going to open up for questions. I mean, this is the end of the the calibration.
Great. So we don't have any questions coming in yet, but if anybody has any questions, please feel free to use the chat feature or the Q&A piece, and we will take a look at you and give you a call. I got a couple questions for you. So you kind of you did go through that fairly quickly. So when you were laying out the calibration, when laying out the targets for it, I noticed you weren't referencing, the information. Where did you get the dimensions for it? Exactly, how to, 4,000 and everything we were commenting
Oh,
on.
in the app. We get that in the Easy ADAS app,
Okay.
which comes with the system in our case. Where's my phone? Here it is.
So that
So I
was,
can show you on the phone here.
so the information for that vehicle is preloaded in the app that you've got.
Yes.
Okay.
Yep. Or if you have a mutual information or all data, any type of vehicle information, system will have that info.
Okay. Very good.
Okay, so mine's not updated either. Or there's also a book that comes with the unit.
Okay. Can you tell us a little bit more about the unit itself?
Unit.
Because that's a piece of equipment that I think a lot of our viewers probably aren't very familiar with. Can you kind of walk us through what exactly that is, and its origin, and kind of give us a little bit of background on the unit itself?
Okay, the unit itself. So we've been doing ADAS calibration since about 2003 with the Volkswagen products, the Audis, the Lambos, and Mercedes, the German cars for the most part, because it is a requirement after an alignment to calibrate their systems. It's part of their modus operandi. Then we looked at the industry, and now these systems are becoming more and more popular. Actually, the consumer is seeking vehicles that have these systems in, because it allows them to, I guess, be more confident about driving the cars in today's environment. So we developed the stands in Lincolnshire, Illinois, and the targets. The scan tool comes from San Jose, our diagnostic partner, and we do most of the testing here in Conway, Arkansas.
Okay.
So we have a stand, the target boards. So the target boards will cover all Asian and all European vehicles for the moment. There are very few US domestic vehicles that require targets. Although this Honda is a US domestic vehicle, still considered an Asian vehicle.
Okay. Very good.
So we talked about the level last time. So this floor here is relatively level, but we had pits in here before. So there are some humps and bumps in certain places. So the floor levelness is about 1 degree over 20 feet. If you look at all the manufacturers, some manufacturers will say 1 degree between the wheelbase and the track width, which is, it's not a whole lot. 1 degree on that distance there, it's a few thousandths of an inch. But 1 degree over 20 feet, it's about 350 thousandths.
Okay. And what could potentially happen if that floor isn't level?
It won't calibrate.
Okay. Very good.
Because if the worst case scenario is what we see is the shop's not long enough, so they park the vehicle on the approach to the shop, and the approach is on an incline. So remember, we're going to level the stand here at some point in time during the process, and you're leveling the stand on a different plane than where the car is parked. So the camera height is incorrect, and the shape of the target changes. Remember, in calibration mode, remove all the filters. So the best example of this is when you go to the eye doctor for your yearly exam, they'll dilate your pupils so they can look inside your eye, right? Your eye socket. So when you go outside, you got to have these sunglasses, otherwise you cannot see. So when the camera goes into calibration mode, it's similar to that. That's how you got to look at it. Because the camera can work normally outside in daylight, but all the filters are applied: infrared, ultraviolet, and then some. However, when you're in calibration mode, all those systems are off, and it's really looking for a high contrast on this target.
Okay. And one thing I don't think can be overstated, and we've talked about it in several of the other ADAS presentations that we've done, is just how important it is to make sure the targets are in the proper location, that we've got the proper conditions, the floor leveling, the lighting, et cetera, et cetera. Because even though, a millimeter or a couple of millimeters or maybe a tenth of a degree or a few tenths of a degree, at the windshield or at the sensor, doesn't seem like that big of a deal. Once we shoot out in front of the vehicle, 100 yards or a roundabout there, we can have some major variances. And the analogy that I've often used, for those of you that might be hunters out there, but with a rifle scope, again at several hundred yards, if those crosshairs aren't where they're supposed to be, and you haven't aimed that and calibrated that scope to the rifle, you're never going to hit your target. And in this case, could be the difference between life and death potentially. A couple more questions I've got for you. For those of you on the call, please feel free to use that chat or Q&A if you have some questions. But one thing that I noticed, Ron, was the use of a laser versus a string. Can you talk a little bit about that? Because I recognize the benefits of it, but I'd like to get it from the subject matter expert about the laser versus a string and some of the factors that some of the issues that you might run into with using a string.
When you when you use a string and a plumb bob, you're going to put the string up here and let it slide down the vehicle, right? So it may just snake there and not necessarily be perfect as the light would be. So the light doesn't deflect, doesn't distort. The laser light's a diode, it's perfectly straight. And it's self-leveling. So you don't have to worry about, am I square up and down? It's always square, self-leveling. So there are benefits for the laser is you can see easier. Also with the laser, I don't have to put a string. Normally, if I'm doing it with the string and plumb bob, I'm going to put an X in the front. I'm going to take the plumb bob, hang it back here, put an X on the ground. Then I have to tape a string on that X and then throw it out the front, pull on it, line it up with my X in the front, then do all the other geometry to find the location for the target. It's really practical.
Yeah, and I've noticed too.
However, wherever you are in the world, if you follow that procedure, you'd probably be successful at calibrating the vehicle.
Mm-hmm. Yeah, when I've used strings before too, again, it's really easy to have some variances in there. Again, if you put that tape down and you move it just a little bit, and again, those tenths of a degree over the course of 15, 20 feet can certainly make an impact on it. Now, I do notice, Ryan, you've got a lot of space there. You talked about the space requirements a little bit, and the lighting. What are some of the challenges when it comes to the lighting itself and the space requirements?
So you want to have a nice uniform lighting, ambient lighting, not too bright. Like sodium lights actually excite the camera and sometimes prevent from getting into the calibration mode because they actually oscillate. So you want a nice ambient light. You don't want too much contrast or too many objects in the back, right? Or forms. Like in some cases when we have to lower the targets here, what I'll do is I'll put a 120-inch projection screen behind it so we can hide some of the black lines on the ground.
Sure. Because that camera and the system that is looking for a specific target, correct? So if you've got clutter in the background, that could again throw everything off.
It's looking for the target at a specific distance, height, and also flatness. So if the target is bowed like this, it's not going to recognize it. If it's concave, it won't recognize it. If it's hanging sideways, if it hasn't been just like this, that would be a problem because the left and right would not calibrate. It simply would not calibrate.
Sure. Cool. And now you mentioned also that as a best practice, something we want to be doing following our static calibration is taking the vehicle for a test drive, correct? Tell us what would be involved in that kind of a test drive, not the dynamic calibration, but what am I looking for when I take the vehicle out for a test drive?
Well, you'll engage the systems. So you leave the scan tool connected to the vehicle and you go drive it and you engage the system to check if your lane departure or lane keeping system is reacting correctly.
Okay. So I need to understand what the system's supposed to do, whether it's a lane keep assist or a lane departure warning. So the first step would be understanding what exactly the system is supposed to do so that I can verify that if it's working.
So lane departure warning can be found on hydraulic power steering vehicle and electronic power steering. Lane keeping can only be found on electronic power steering and some BMWs that have a hybrid system where there's an electronic controller on the spool valve that can actually move the cylinder and steer the front wheels, the power steering cylinder. So lane departure will notify you that you're leaving the lane and heading in the adjacent lane right next to the vehicle. Lane keeping will notify you, but steer the vehicle so you do not enter the adjacent lane.
And again, I think it's important to understand the difference between the two and what the vehicle that you have, has, which system it has, because if the vehicle is only equipped with lane departure warning, and I'm expecting it to bring me back in the lane, there's going to be, I'm going to think there's something wrong with the system because the system isn't designed to do that. So again, it's really important to identify early on which of these systems the vehicle has. And then when I do my test drive, when I'm verifying that it's operating properly, I need to, again, reinforce that and understand exactly what the system is supposed to do. So,
And the consumers are complaining in some cases where I'm trying to move in the lane and it won't let me because the blind spot system is seeing a vehicle, and the lane keep system, the blind spot system, monitoring system talks to the power steering system, and it says, hey, you can't steer, there's a car there. So the steering wheel gets real heavy, and then it wants to steer you back in the lane. You can't steer.
Sure. Great. Right. Well, I'm not seeing any other questions coming on. Paul, do you have anything that you want to add or ask that we could cover? Or Ronnie, anything else you want to mention?
No, I just wanted to do a quick demo because a lot of people think this is really complicated, and it's really not complicated as long as you follow all the steps.
Yeah, I think that's a great point. It does definitely take some reading and comprehension. We want to understand exactly,
Yep.
Again, what the vehicle's equipped with, and understand, exactly what it's supposed to do. But we do have to read and understand and go through those steps line by line to make sure that we know exactly what we need to do. And I'm just pulling up here real briefly while we've got this. So for that camera, for the rearview mirror, I just want to let everybody know on the CRV, just as an example, because again, here's another area where having access to that OEM information early on in the process when you're blueprinting that vehicle is vital to making sure that you can develop a solid repair plan. So for the multi-purpose camera that we just kind of went through on the CRV, the calibration isn't required only if there's an issue with the camera or only if you replace the camera. I'm reading right from Honda here. So calibration of that camera is required if the windshield is removed, installed, or replaced. Yes. If the multi-purpose camera unit is removed, installed, or replaced. If structural repairs are made. So if I do structural repairs on it, Honda is requiring a calibration of this camera. If a supplemental restraint system has deployed after a wheel alignment, or if a DTC indicates a calibration is required. So a lot of different calibration requirements for this particular vehicle. So if you've got a Honda CRV, this is a 2019, 2018, what's it model year?
2019.
2019, which is what I'm looking at right now. So again, if I'm doing structural repairs, if I've got an airbag deployment, if I've got a wheel alignment on it, that camera has to be calibrated each and every time. So again, it's important when we identify early on in our blueprinting process and our damage analysis process that, hey, I've got a CRV here, I'm doing some structural applications, I've got a deployed airbag, even though I'm not touching that camera, even though I'm not touching that windshield area, calibration may be required. So again, each and every time when I'm working on these vehicles, I need to go into that early on and identify all the different ADAS systems on there, because this vehicle could also be equipped with adaptive cruise control as an option on the CRV, collision braking or emergency braking is an option, blind spot, which is becoming pretty standard. Still has a side view. The lane watch camera might be on this one as well. So again, it's really important that we know exactly which systems the vehicle has, and then start to identify when calibration is required, so we can plan for that, plan accordingly for our repair plan, and make sure that we're getting taking that into consideration when we're building out a repair plan.
And you should do a pre-scan on every vehicle. And I just read some data this morning. Only 13% of the collision industry is actually doing a pre-scan. And there could be codes and all kinds of information in there that you don't know at that time. And then suddenly after you do the repair, things are coming on, lights are coming on, customers coming back, and you don't know if those codes were there before or if it just happened after the repair. That's why it's so important to do a pre-scan. It's like when you go to the doctor, right? Temperature, pressure, very important.
Yeah, that's a great point, and I would also include the analogy of three-dimensional measuring. You know, because when we get the vehicle in, if we don't three-dimensionally measure the vehicle, we have no possible way to identify all the structural damage on there. So the
True.
setup and measure is one operation, and then the actual pulling procedures themselves are another operation, or the part replacement's another operation. Same thing with the pre-scan. That pre-scan is kind of likened to that setup and measure, and then the collision repair diagnostic part of it, identifying, if I do have diagnostic trouble codes there, what are they? What are the causes of them? Are they collision related? Are they not collision related? And trying to decipher through that and identify what exactly needs to be repaired. That's again kind of back to that pulling part of from a three-dimensional standpoint analogy on it. So it's really important that we do that initial scan to identify if there is some diagnostic trouble codes in there, some other issues that we may not be able to see with our eye, and then build out that diagnostic, that collision repair diagnostic piece of it to build our repair plan, replace all the parts, and then go through the calibration. Because again, pre-scan, post-scan aside, the calibration part of it is not included in that. That's an additional operation. Again, we walked through this
True.
fairly quickly, and Ron's done a lot of these, so he understands how to go through the process. But for us collision repair technicians, the first couple times we go through it, it's going to be a little bit more of a tedious process. We really need to understand what we're doing to set those targets up and make sure that we're following everything properly, to make sure that we're calibrating those systems properly. Then do our test drive again, check for codes on it. So it's a quite an involved process. And you mentioned the pre-scan, and that not a lot of people are doing it, or not enough people are doing it. But that's something that really needs to be done on each and every vehicle that we've got working on today's vehicles.
True.
Again, or it is impossible for us to write a complete assessment of that vehicle and develop a complete and comprehensive repair plan unless we know, again, if all the electronics on that system, not just ADAS systems, but any other electronics associated on the vehicle. I need to identify all that damage. Very much like I said with the three-dimensional measuring, we need to identify where all the damage is on that vehicle so we can develop the most effective repair plan on it.
And remember, Jason, some codes don't turn any lights on.
That's a good point. Can you walk us through that a little bit? Because I want you to stress that again from your subject matter expert here, understanding that not all these codes turn on lights. Could you say that again, and maybe a little bit more slowly for all of us that still think that way?
Yeah, some codes won't trip a trouble light on. For example, some emission codes require 2 or 3 drive cycle. And the drive cycles sometimes are very involved. You have to drive the car for a certain distance, a certain speed, and then change speeds. And their drive cycles are just not a single event. So you have to go and drive that vehicle. And they may see something wrong and say, okay, I'm going to put this here in the pending codes. I'm going to keep watching that component. And if that happens again a second time, then I'm going to turn the light on. So you bring a vehicle in and it's on the first cycle. You work on the car, you deliver the car to the customer, you didn't check the codes, customer leaves, he's on the second cycle, the light comes on, he's back at the shop, and he'll say these famous words, that light wasn't on when I dropped it off this morning.
Yeah.
So now you own that, you're gonna own that, right? That happens a lot with ABS systems. It happens with emission systems. So it's very important to document yourself when the car comes in, because you can go from an opportunity to a liability in a fraction of a second, right? And we need to protect ourselves. So the vehicle has information and it can communicate that information. It's important to dig in there. Power steering, electronic power steering system may have a code in there like a DTC 1023, which is an overcompensation code. So the car is pulling, the electric power steering can't compensate for the pull anymore. Doesn't turn any lights on. So the customer is complaining of a pull. So if you're a technician and you know about the electric power steering, you would say, well, that's relatively impossible because the system should compensate for that. So you have to go in there and look for those codes.
Sure.
And so even some of the ADAS codes will not trigger a light on. They may change the behavior of the vehicle, but they will not trigger a light on. So the manufacturers, to improve the customer experience with their vehicle, are trying all kinds of tricks not to get the customer to come back for minor problems or issues, so to speak.
And I would add to that too, when it comes to diagnostic trouble codes versus malfunction indicator lamps. those malfunction indicator lamps are designed for the owner of that vehicle. So if I've got an amber light on, that tells the driver, hey, you know what, you've got an issue of some sort with this vehicle. You should probably bring it in for service. If it's got a red light, that's saying, hey, we have a major issue here. It's a safety related issue. You need to bring this vehicle in for service now. The diagnostic trouble codes aren't for collision repair technicians, aren't for service technicians. Sure, they're good indicators to help us kind of guide in that direction. But as Ron mentioned, not all these are going to turn on malfunction indicator lamps. So it's really important for us to hook up the scan tool, to do a scan of all those different modules and look and see if I do have any existing diagnostic trouble codes. I need to use that. The vehicle's been involved in a collision, so I need to use that collision advantage to help me to identify where that damage might be located, what I'm looking for. So
Mhm.
there's a lot of different pieces that I need to rely on, but the malfunction indicator lamps is just one small indicator that I want to check on. I'm not saying ignore them, certainly, but it's definitely not the telltale sign there's something wrong with the vehicle. Again, very much like the doctor analogy we used before. If we have a pain or something, our nerves are telling us as the driver of that vehicle, hey, you may want to go in and take a look at it. That doctor's going to have to do some additional testing on us to identify, what those diagnostic trouble codes might mean in our body. And then we need to develop that repair plan and that
Yep,
diagnosis of what exactly is wrong with us before we can go ahead and fix that.
exactly.
So we got one more question. I'm going to frame it up a little bit more differently than it was posed to us. So what's the difference between what the factory does when they're putting together, when they're initializing or calibrating the system off the line versus what we're doing? Are there any differences between the two processes at the factory versus following a repair?
Yes, actually, at the factory, they only calibrate one vehicle. It's always the same vehicle, right? It's the same. It's a Honda Civic, another Honda Civic. So they have different setups for that. They can do it faster. Some of them have rollers where they spin the wheels. They do a dynamic calibration, even in a static mode. Some they just do a static calibration, but instead of having a stand, they would have the target mounted on a like a cantilever, and they just lower the targets in position. They click on calibrate, and they calibrate. They initiate the calibration,
But we're
but it's
doing
all done
essentially
at
the
the
same
end of the
thing.
line.
We're kind of doing the same thing, right? We're teaching that system, that camera, that hey, here's the target, here's your known target, and it therefore it knows that it's at X amount of distance, that's X, it's at Y
Yes.
height, etc. So you're kind of teaching it the same thing, but just in a different format.
It's easier at the factory because you're working with the same vehicle, so all the objects, your stand will be at the same distance all the time, right? So where the independent repair facility is going to work with different vehicles that have different requirements. For example, a Hyundai, you'd start over here, then you'll move it about 4 feet back. It's two position. So at the factory, they would have that target mounted on a rig that actually moves back by itself. So more automated.
Sure.
But the process of finding the front center line, center point, the rear center point, establishing the center line, that is the OEM procedure. That's how they do it. And the reason why they recommend using a string and a plumb bob is that anywhere in the world, if you need to calibrate a system and you have a string and a plumb bob and the target, you probably would be successful if you follow that procedure. It's just going to take you a little longer to do.
Sure. All right. Well, I'm not seeing any other questions coming in. I don't know if Kristen's got anything to add or not. But if not, and again, no Q&A. If anybody has any questions following today's presentation, you can certainly reach out to me at jason@collisionhub.com, and I will forward those on to our friends at Snap-on. Tomorrow we're back again, another ADAS presentation tomorrow from our friends at iCar. A couple of former peers of mine, some gentlemen that I've got a lot of respect for, Scott Van Hooley, Bud Center, and Jeff Poole are going to be joining us. So they work at the Tech Center in Appleton, and I'm really excited to see those guys. I haven't seen their smiling faces for a while, so looking forward very much to that. That will be tomorrow morning, again at 11 a.m. Central Time. And until then, again, Snap-on, thank you very much for your time and your commitment to supporting the Collision Hub webinars and keeping the collision repair industry up to date on some of this new technology. It's been an absolute pleasure to work with you, and I thank you very much for your time, and to all of our attendees as well. I will be uploading this. We will be uploading this again to the same Collision Hub YouTube channel that the other webinars have been on. So those will be up later today or tomorrow morning. So check back. For those of you that have peers that weren't able to join us today, they will be that will be available in the not too distant future. So with that, again, Ron, thank you very much for your time today and for the presentation. And we really appreciate it. It's been great. Thank you very much.
You're welcome, and thank you for the opportunity. We really appreciate it.
Great. All right. Thanks, everybody. Have a great rest of your day.